Hi friends, welcome back. Today we are going to solve another interesting graph related coding interview problem, Kth connections. So this is quite interesting graph coding problem that we are going to understand and we are also going to implement our Java solution code to solve this important graph problem. If you haven't already subscribed to this channel, please subscribe to this channel now. Also click on the bell notification icon button right away so you won't miss any important postings from this channel. Here we create videos to help others in their interview preparation and learning different computer science concepts along with data structures, algorithms, problem solving, Java programming and coding. So let's start. You have been given a graph of social media network where ages array contains age UI, VI. It means that there is an age between person UI and VI. The age shows that person UI and VI are connected to each other. The edges are bidirectional. So this is important. The edges are bidirectional. You are given a start person and you need to write a program to find all the persons in the given graph who are at distance k. One edge means one distance. Okay, so this is what the problem says. So it's a social media graph that is given to us. So it will be more clear once we look into example. So this is one of the examples. So there are people here who are connected just like a social media graph, right? So for example, 0 is connected to 1 and they are saying that 0 is connected to 1, this distance is 1. 1 is connected at distance 1 to 2 and distance 1 to 3. So this is 1 to 3 is distance 1, correct? So how much is the distance from 0 to 2? The 0 to 2 distance will be total 2, correct? Because this is 1 plus 1. So this distance is 2, correct? 0 to 3 distance will be 2. 0 to 1 distance 1, 1 to 3 distance 1. So total distance between 0 to 2 and 0 to 3 are 2. So if someone asks us find out the connections which will start at 0 and which are connected at distance 2, right? So distance is equal to 2, let's say, right? Distance is equal to 2. So if distance is equal to 2, you can easily find out that the connections will be 2 and 3 from 0, right? Starting point will be given to us, which is 0, let's say, right? So this is what the problem is asking. So here one another example here, right? So they have given us an example where starting point is 0. So this is where your starting point is, and you want to find out all the nodes here which are connected at a distance k, which are distance is 3, right? So you can just visually look here which are the nodes which are connected at distance 3. So 4 will be connected at distance 3, right? 1, 2 and 3. So this distance is 3, so 4 is definitely connected. From 0 to 4 it's a distance 3. From 0 to 5 also it's a distance 3, right? This is 1, this is 2 and this is 3, correct? So 4 and 5 is distance 3. How about 6? 6 is also distance 3, right? 1, 2 and 3, correct? So 6 is also at distance 3 from node 0, right? So you have to answer 4, 5, 6. As you can see, 4, 5, 6 is the answer here, right? So this is what the problem is asking. Okay, this input ages array is given to us. So this is given to us, right? So this is just a representation of a graph that we are seeing here, right? So if you create a graph from these ages, this is how the graph will look like. As you can see, there is a age from 0 to 1, right? 1 to 2 there is a age 1 to 2, right? 1 to 3 there is a age, so this is a 1 to 3 age. 2 to 4, right? 2 to 4, then 2 to 5, 2 to 5 and then 1, 3 to 6, 3 to 6, right? So this is just a graph representation that I'm showing you. The ages array is given to us, right? Now let's take a look at another example here. So another example is where your starting point is 2, right? Starting point is 2 and your k value is equal to 2. So you want to find out all the nodes which are at a distance 2 starting from node 2. So which are those nodes? This node 0 is at distance 2, correct? From 2, and node 3 is also at distance 2, 1 and then 1 is 2, correct? So 0 comma 3 will be your answer in this case, right? So this is what the problem is asking us to find. So now you understood what the problem is with this example, I hope. So how can we solve this problem? So what we can do to solve this problem is we have to first take this edges array and we have to create a graph, right? Graph we can create using adjacency linked list, right? Adjacency linked list. So what adjacency linked list tells us is how the nodes are, like which are the neighbors of that node. For example, the nodes for neighbors of node 0 will be 1, correct? Right? Okay. Neighbors of node 1 will be 0, 2, 3. So these are the neighbors of node 0. Why? Because as you can see, one is connected to 0, one is connected to 2, one is connected to 3. Correct? Right? So 0, 2, 3 are the neighbors of 1. So similarly, you will create a graph like this. Who is connected to 1, 4, 5, right? 1, 4, 5. Like this. So this is a basically we call in computer science as a adjacency linked list, or this is also a graph representation in programming, right? So 3 is connected to 1, 6, right? And 4 is connected to 2 and so on, right? Okay, and you can create other thing, right? So this is the adjacency linked list we will create. Then what we will do, starting point is given to us, so we'll go to this starting point, so 0, right? So after that you can do a, like you can go from 0 to its neighbors, right? So something similar to BFS, right? So you can go to 0 to 1, then you will keep incrementing the steps, right? So steps will tell you the connections, the distance basically, right? So steps is equal to 1, it means that from 0 to 1 your distance is 1, correct? Now from you go to 1 and you will visit its neighbors, right? So which are the neighbors of 1? 0, 2, 3, right? So you visited 1, correct? You started from 0, you visited 1, now you will visit 0, 2, 3. So 0 is already visited, right? Because we'll keep track of the nodes that we already have visited in a set. We will keep them in a set so that you already knows that they are visited. So you will not visit 0 because you already visited 0. 2 you will visit, so you will visit 2, and 3 you will visit. So you will visit 3, right? Okay. You will add them into a set because these nodes are already visited, right? 2, 3. So this is visited nodes. You will increment the distance. So your distance is 2, right? Now you will visit the neighbors of each of these nodes. So you will add these nodes into a queue because we will use a BFS, right? So we'll keep adding these nodes into the queue. So what your queue will contain now? The queue will contain, first it was containing 0. So you removed 0, you visited 1, 1, right? Then you added 1, you visited 1, correct? Then you visited 2, 3. So you added 2 and 3 here now. You got it, right? So this is how this is a queue basically, correct? Because BFS uses a queue, right? So we will also use a queue. Now next time you will remove this 2, 3, right? And your step will be increased by 1. So now your step is 3. So you remove 2, you visit its neighbor, right? So 2 neighbor, which are 2 neighbors which are not visited? 4 and 5 are not visited. 1 you already visited, right? So 4 and 5 are not visited. So you will visit 4, you will visit 5. You will check your steps. Steps is equal to k. Yes, steps is equal to k. It means that this is at a distance k. So you will add this 4 and 5 into your output, right? So this is your output. You will add 4 and 5 because this is at distance k now, correct? You got it, right? Because this is at distance 3, 1, 2, 3, right? This is also 1, 2, 3, correct? So you will add it into your output list. So you removed 2, then you removed 3, you will add its neighbors. Neighbors of 3 which are not already visited is 6, right? So you will add 6 into your output, right? So this way you can find out the kth connected node from that starting node, right? 4, 5, 6. This is what the answer is, right? So this is a BFS and queue based logic we will use to solve this coding problem. So this kind of problems often get asked in the interviews, which are graph related problems, which you can solve it using BFS and this approach. So that's why I wanted to show you this approach and this logic, so you can also solve these kind of problems. So now we'll go to the Java code. So it will be more clear for you. Understood this logic, I hope, clearly with this example. So this is our Java solution code. So n is equal to 7 means there are total 7 nodes. Ages array is given to us. This is the same ages that you are seeing here, right? This is the same example basically. Your starting point will be given to you here, which is a 0. Your k is 3 and total number of nodes n is given to you. So here we are actually creating a graph. So this is the adjacency linked list, right? And we are going to first create a empty linked list and then we will add the edges. So after you add the edges, this is where the add edges method is, right? So you are creating a graph basically from the given edges, right? And graph is represented as a adjacency linked list, correct? So here you read the age has two values, from and to, right? Where the age goes from towards to, correct? So E0 to E1, and this is a bidirectional age. So as you can see in this add age method, you get u comma v. So you are adding age from u to v and from v to u, because this is a bidirectional age, right? It goes from both ways. It means that person A is connected to person B. It also means that person B is connected to person A, right? So there is no direction here. They are both, connection is on both directions. So this is how you create a adjacency linked list here, right? So this is just a static, so you can access it anywhere. So this is a holding integers, and this is a adjacency array, right? Why array? Because we want to keep adjacency linked list for each node, right? Because it can have multiple neighbors, right? And this visited set is a hash set of integers to keep track of the nodes that you already have visited, right? And this is the constructor of kth connection graph, right? Okay. Now the graph is ready, so we are going to call the find k connections method. Starting point is 0 and k is 3 here, right? So you get the starting point here, you get the k value, which is 3, right? N is 7 in this case, correct? Now we will create one boolean array here, right? So boolean array will keep track of the visited nodes here, right? In this boolean array. After that we will create a queue, right? Because we want to use BFS. So this is the queue creation, right? So queue is essentially a linked list and it is going to hold integers, right? Queue. After that we will mark the starting point as visited, because now we already have visited that node, because we are adding that node into the queue, correct? Because we need to have something into the queue for doing the starting the BFS, right? We already know the starting point, so we'll add a starting point into the queue. We will create a result list, which is a array list of integers, right? Because we want to return a list of integers as a return for this method, right? Then step is equal to 1 in the beginning, correct? Now this is where our actual BFS starts. I'll write down here BFS starts, right? So this while loop will keep looping until the queue becomes empty, and it will first check the size of the queue, which is current size, so that it can process those many elements, right? Because how BFS goes, it goes level by level. That's why it is also called as level order traversal, correct? Okay. So now you know the current size, so you have to process those many elements that you can process through this for loop. So a is equal to 0, a is less than current size a plus plus. So you actually remove the current element from the queue. The current node you remove from the queue, Paul will remove, okay, remove from the queue. After that you will add it into the visited set, right? And you will also now you have to go through all the adjacent neighbors for that current node. So adjacent linked list you will use here, right, which is a graph. So adjacent linked list of current node will give you all the neighbors, right? And you will create a list iterator so that you can go through all of its neighbors. So it will give you the iterator object here of integer, and you will use this while loop to iterate through this iterator I dot has next. So you are iterating through the iterator and you are visiting all its neighbors, right? So this is where you will visit all the neighbors, correct? I dot next will give you the neighbor. You will check if the step value is equal to k, means this neighbor is at a distance k basically, right? And neighbor should not be equal to the start node, correct? And it should not be already visited neighbor, correct? It should not be a already visited neighbor, then you will add it into the result list, right? So it means that if it's a kth connection from the start node basically, so you are finding a kth connection from the starting point, so you have to add it into the result list, right? Because it's a kth connection. Otherwise, if it's not a kth connection and it's not a visited neighbor, then you have to add it to the queue and you have to mark it as a visited, right? So visited neighbor is equal to true, correct? So this is how the code works. After this one, every iteration you will increment a step by 1 point, correct? Every iteration you will increment the step by 1 point because you are going to the next level now, right? So what I mean to say is first, so I'll remove all these colors now. You understood this? So what I mean to say is from 0 you will go to the first level is this one, right? This is your first level. Then the next level is 2 comma 3. This is your next level, right? So next level, after this the next level will be 4 5 6. So it goes like this, level by level. So this is level 1, right? This is level 2, this is level 3, which is level 3 is what we want to consider here because k is equal to 3, right? So you will get 4 5 6 here basically, correct? So this goes level by level. So that's why we'll have to increase the step is basically a level here, right? At the end you have to just return the result list, which will give you all the nodes which are at a distance k from the starting point, correct? So this is how you can use BFS and the queue approach to solve this coding problem. So I hope you understood this code. So now let's run this code and make sure it gives us correct answer. So what we are right now expecting here is 4 comma 5 comma 6 because we are starting at node 0 and we are considering k is equal to 3. So 4 5 6 is the correct answer, as you can see here, right? 4 5 6. If you start at 0, if your k is 2, you will get 2 comma 3, right? So let's test that. If your k you change it to 2, you should get 2 comma 3, right? So let's try that. So you are getting 2 comma 3, which is correct answer. If your starting point is 2 and you want to find out the distance 2 nodes, right? So let me just, so you are actually here, right? You are here. You want to find out distance 2 nodes, right? So 2 nodes will be 0, right? 0 will be one of your 2 nodes and the other 2 node will be 3, correct? 3. So 0 comma 3 is what you should get now. So let's test it out. So 0 comma 3 is we are getting, which is a correct answer. So we are getting correct answers. So this is how you can implement this Java code and solve this coding problem, kth connections, right? So I'm going to add this Java solution code in my GitHub repository and give you the link of this Java code so you can check it out. There are lots of other important algorithms and Java solutions already implemented and available there for you. So don't forget to check out the other Java codes from the GitHub repository. If you like the Java solutions in the GitHub repository, consider giving it a star on the GitHub repository. That would be great. If you are new to this channel, there is a very important coding interview related playlist we have created to help your interview rounds. It is called as LeetCode and LeetCode Solutions. More than 200 most frequently asked very important coding interview problems are compiled for you under one playlist. Those problems are asked by Google, Facebook, Amazon, Apple, Microsoft, Yahoo many times in their past interviews. They are very important coding interview problems. Make sure you go through all of them, understand them very well. If you go through all those videos, you are going to learn a lot about data structures, algorithms, problem solving, logic building, Java programming and coding. It will also help you learn lots of new techniques, lots of new ways of different varieties of problem solving. So make sure you check out those solved coding problems. The name of the playlist is LeetCode and LeetCode Solutions. Now, if you are a fresher, junior level developer and you want to practice more coding problems, to help your practicing purpose, we have created 3 other playlists here for you. The names of those playlists are Codeforces, CodeChef, AtCoder. Codeforces, CodeChef, AtCoder. All in all, more than 800 different varieties of problems are here to help your interview preparation and learning process. If you like this Java solution where we have used the concept of BFS, which is breadth first search, along with queue and this approach, then please give it a thumbs up to the video, give it a like to the video, subscribe to this channel. Subscription is very important because that's how the videos can reach to other people. so others will also be able to watch and learn from these videos. So do subscribe to this channel, share this video with your colleagues, your friends, so they will also learn more programming and problem solving. Click on the bell notification icon button right away so you won't miss any important postings from this channel. On this channel you will find lots of solved coding problems explained with Java code for your clear and easier understanding. Those solved coding problems includes graphs, matrices, binary trees, breadth first search, depth first search, Cadence algorithm, binary search algorithm, Kruskal's algorithm, Dijkstra algorithm, sliding window algorithm. There are also lots of important data structures coding questions available here for you, including stacks, queues, priority queues, hash table, hash map, reset, hash set, linked hash map, linked hash set, arrays, linked list. All those problems come with Java Solution Code, where the code is available in the GitHub repository. You will always find out the link to all the Java Solutions code in all the videos description sections, so that you can go check out the code, play with the code by creating your own custom input test cases for your easier and complete understanding of the solutions. If you are a fresher, junior level developer planning to take Java rounds of interviews, there are lots of Java related videos available here. For example, frequently asked Java telephonic interview questions and how to answer them, Java design patterns, Java architecture, SQL programming questions to the freshers, where they will give you database tables, they will ask you to write SQL queries, where you have to use different database concepts like joins, aggregate operations, group by and having clauses, different where clause conditions. Everything is explained in those videos with examples for your easier and clear understanding. Um, if you like the videos on this channel, if they are helping your learning process, you are learning new techniques, more problem solving along with data structures, algorithmic techniques, Java programming and coding, then please do leave your messages, your feedback, your comments below these videos. Your messages, your feedback, your comments are highly appreciated, very important and valuable for us. They increase our motivation to create more quality content videos. So do leave your messages, tell us how the videos are useful and helpful for you. If you want us to create videos about any specific computer science, Java J2E or interview related topics, then also mention those topics in the comments section below these videos, so that we can create those videos for you here. Keep learning, keep coding, keep solving more varieties of coding problems, and most importantly, keep your learning process and practicing going on continuously. And thanks for watching these videos.